Hey everyone. So, no shocker, I'm still sick, so I apologize in advance for if I cough. I hope it doesn't give you a heart attack like last time. I just want to start with going over your polar exploration sheet, and then the rest of the class is your time to work. But I just wanted to clarify any questions that I think you might have. So this is what you did last class. You went through on Desmos or on your TI, and you hopefully went through all the different problems. So I'm just going to point out some of the things you hopefully noticed. So rose curves are when you're not adding or subtracting two values like in front of the sine or cosine. It's just number times sine or cosine and then a value multiplied by the theta. So that number multiplied by theta is called your n. So the n really affects a lot of things. So if your n is even, then you're going to have double the amount of petals. So you'll have 2 times n petals. So here our n was 4, so we had 8 petals. If it's odd, then you're just going to have the same number of petals. So 5's odd, so I have 5 petals. A represents the petal length, so the value in the front is your A, and so that value in the front should just show how long, like on that polar graph, how long those petals should be. So these should all touch 3. For a cosine curve, when it talks about the first petal, if you graph it on a TI, you'll see the first petal graphed is on your x-axis or on your polar axis. So on a cosine curve, you're always going to have your first petal on the polar axis, and it's going to have polar axis symmetry. So hopefully you notice on all your cosine graphs, you've got symmetry on your cosine graph. I'm going to cough just so you know. Okay, for a sine rose, sorry, my sheet's messed up, but there will be no petals located on the polar axis, and the rose is going to have a pi over 2 symmetry. So notice all of the sine graphs have symmetry over that pi over 2 line. So these are tricks to help you graph things by hand without having to do the whole charts. So this should be intuitive, but if n is 1, you're going to have 1 petal. And cosine, we know, has symmetry around the polar axis or the x-axis. So it's going to be 1 petal on the polar axis. Sine has symmetry around that pi over 2, so it's just 1 petal at the pi over 2. The next type of graph we're going to deal with are Lemniscates. And they are when you're adding like an a and a b value in front of your sine or cosine. So here's what your graphs hopefully looked like. It was good if you wrote down like how far out this like singular petal went, and looking at these 2 points where it crossed, you could notice a few patterns. So I did all 6 graphs on one page because you did the first 4 on the front page, second 4 on the back page. So I just wanted to show you all of them together. So different patterns that you could see, or that you hopefully noticed. So if these two are, okay, first of all, whatever the A value is should be where your graph is hitting on the x-axis, or on the pi over 2. So our A value should equal the points that we hit here. So here, like A is 3, hits at 3 and 3. Here, A is 1. So it's hitting it here and here. So that one should be straightforward. Your A value is where it's hitting on that pi over 2. The next thing to look for is how far out it goes. So like how big the petal is. So the way to find that value is you add your A and your B together. So here my A is 3, my B is 1. So 3 plus 1 is 4. So 4 is how far out it goes. Here we've got 3 plus 3 is 6, so it goes all the way out to 6. So even when it's a negative, you're doing the absolute values of the numbers. So 3 plus 5, that gives you 8, so it's going out to 8. Then to figure out where this other side goes, so for the positive ones, the left side, what you're going to do is you're going to take your A and you're going to subtract the B from it. So I'm going to find this value, you're going to do A minus B. So here we've got 3 minus 2, and that gives me 1. So my point here should be at 1. This one's special. It's like 1 minus 3 is negative 2. So instead of going to the left 2, I went inside 2. So that's how we got that point there, and we're getting that inner loop. When your number is a lot bigger, so here we've got like 3 minus 1 is 2. So we hit here. Notice when the A value is a fair amount bigger than your B value, you don't have a dimple or an inner loop. you are going to have a concave or convex, shape. When they match, that's the special case, which is a cardioid, because it looks like a heart. Because 3 minus 3 is 0, so we just sit on the 0. So for that, the left side point, you're just going to do a minus b. Even when it's negative, you're still going to do 3 minus 5, and that gives me the negative 2. So I'm going to go inside 2. Notice this graph is flipped, so instead of being on the, mostly on the right, it's on the left, and that is because of this minus sign. So whenever we see the minus sign, we're going to reflect the opposite direction. So instead of being on the right, it'll be on the left. For a sine graph, the minus sign means instead of being up, it's going to be down. So something else to look at, your cosine graphs, we know, have that polar axis symmetry, where sine graphs have the pi over 2 symmetry. So here we've got that pi over 2 symmetry. I think that's all the main points for the Lemniscates. So all of those are, the rules are talked through here. So if you want to pause and look through all of these, but everything I just talked about is stepped through on these different rules. The last thing are the Lemniscates, and those are if you've got r squared equals a squared cosine 2 pi, or the same thing with sine. Hopefully when you graphed it, you figured out that because you have r squared, you can't do that. So instead you would just square root both sides. So you would graph the square root of cosine 2 pi. I think on Desmos you only need to type it in this way, and it's going to give you the nice infinity sign. On the TIs you'll probably have to do both. So notice you're going to get the infinity sign for cosine, and that'll have that nice polar axis symmetry. On a sine graph, you're going to have symmetry along pi over 4. And once again, the a value represents your petal length. All right, so that is your whole sheet. So now that you know all of that, you've got your rules. These are like your notes. This is the homework that we talked about that was supposed to be homework yesterday, but we're now making like an in-class activity. So I'm hoping everyone's going to finish this by the end of class, and then no homework over Thanksgiving. So please spend the rest of class working on this worksheet. It's double-sided. If you want to work with people around you, that's fine. But I want you to get this done by the end of class. I want to stamp it for everybody when we come back after Thanksgiving. All right, I hope you guys have a fantastic Thanksgiving. Have fun and eat lots of good food. And pie, lots of pie. Bye.